Okay, let's unpack this. We're diving deep today into a market that's, well, it's booming, it's complex, and frankly, it seems to have a bit of a trust problem.
You're talking about the voluntary carbon market.
Exactly. This is where, people, companies, they buy these carbon credits. The idea is to offset their emissions.
Sounds simple enough on the surface. Buy a credit, 1 ton of CO2 gets removed or avoided somewhere else.
Right. But the sources you shared, articles, research, even some white paper bits that really paint a picture of significant skepticism. Are these credits actually good quality? Are they effective?
And that skepticism, it really comes down to a few core things. The whole landscape is fragmented.
Fragmented how?
Well, you've got multiple different ways credits get certified, which honestly can just confuse buyers. It makes it really hard to tell a high-quality credit from a low-quality one.
Okay.
Plus, there's often a real lack of transparency in the monitoring, reporting, and measurement, the MRV, as it's called.
Right, the MRV. So you don't always know if the claimed emissions cuts are even real. Or even worse, maybe the credit you bought isn't unique.
That's the double counting issue, and it's fundamental.
If someone else is claiming the same reduction, it kind of kills the whole point, doesn't it?
It absolutely undermines confidence. If you can't be sure that credit represents a unique, verified climate benefit, the whole system just, well, it struggles.
Okay, so we've got this landscape. Confusion, potential double counting, lack of clear proof of impact. But our sources seem to pivot towards a potential, maybe game changer.
Something that came out of the digital world originally for transactions, but people are now looking at it for these, real world environmental problems.
And that would be blockchain technology.
Exactly. Blockchain.
So that's our mission for this deep dive. We're going to use these sources as our guide and really trying to figure out how blockchain, with its specific features, could actually address these trust and transparency problems in the carbon market.
Yeah, what do the sources say this technology actually brings to the table? It's fascinating, really, seeing how these basic blockchain principles might solve problems that have, frankly, plagued this market for years.
Okay, so before we get to the solution side, let's really pin down those core problems in the voluntary carbon market, according to the sources.
Yeah.
Beyond just general skepticism, what are the big pain points?
Well, the sources hit on it again and again. Widespread doubt about the quality, the actual effectiveness of the credits.
Right.
Then there's just the sheer number of different groups doing the certifying. You'd think that means higher standards, but often it just creates noise, confuses buyers, makes it hard to compare like for like.
Apples and oranges, basically.
Pretty much, and that lack of transparent MRV means verifying the actual climate impact, after the credit is issued. It's incredibly difficult.
And that double counting you mentioned earlier. How does the current system even allow that to happen?
Well, in a lot of the traditional registry systems, it can be really challenging to have one single universally verifiable record for every credit.
So, silos.
Kind of. A credit could potentially be marked as retired in one system, but then maybe intentionally, maybe not, it gets claimed again somewhere else. That risk just fundamentally eats away at the credibility you need.
Credibility for companies, individuals, anyone trying to trust they're actually making a difference.
Precisely.
Okay, problems laid out. Now let's look at what these sources propose as the solution. Blockchain. Fundamentally, what is it? Why do they think it fits here? Let's get beyond the buzzwords.
Okay. So, at its core, blockchain is a decentralized, distributed digital ledger.
Okay, break that down. Ledger is like a logbook.
Yeah, think of it like a shared logbook, but instead of one person or company controlling it, like a single spreadsheet,
Mhm.
it's shared and constantly updated across many, many computers. That's the distributed part.
And decentralized. That means no single boss.
Exactly. No single entity has exclusive control. That makes it really resistant to manipulation by any one party. And a key feature that flows from this is immutability.
Immutability, meaning it can't be changed.
Once data is added and verified by the network's rules, it's incredibly difficult to tamper with it or change it after the fact. Practically impossible without enormous computing power to rewrite everything that came after.
And this shared logbook, can anyone see it?
Well, for public blockchains, generally, yes. It's publicly visible, trackable. Anyone can usually look at the history of transactions recorded on it.
That sounds like a big shift from some current carbon registries, which can be pretty opaque.
It's a major contrast, yeah. Transparency is built in.
So how does this network of computers agree on what actually gets added to the logbook? How do they trust each other?
That's handled by what's called a consensus mechanism. Think of it as the rulebook everyone agrees to follow to validate transactions and confirm the state of the ledger.
Okay.
It's designed to ensure everyone, or at least the validators, are incentivized to act honestly. Then you've got another important piece: smart contracts.
Right, the source that used the online vending machine analogy.
That's actually a pretty good way to think about it. They're basically self-executing bits of code that live on the blockchain.
Self-executing.
Yeah, you define the conditions up front, like, if X happens, then do Y. When those conditions are met, the contract automatically executes the action.
Like issuing a carbon credit once monitoring data proves it, or retiring it when someone claims it.
Exactly, all without needing a person in the middle to manually trigger it.
And there was mention of digital signatures, too.
Right, that adds another layer of security. It's a way to use cryptography to securely link an action on the blockchain back to a specific party, which helps limit fraud risk.
Okay, so let's recap the building blocks.
Mhm.
Decentralization, immutability, transparency, consensus rules, smart contracts, digital signatures. These are the things that sources say can help rebuild trust.
That's the core toolkit, yes.
All right, let's connect the dots then. How do these fundamental blockchain concepts actually start tackling those carbon market problems we laid out? How does it enhance the system in practice?
Well, the most obvious application, I think, is that enhanced transparency and traceability.
Because it's public and immutable.
Precisely. You get this clear, auditable trail for every single carbon credit from the moment it's issued, based on hopefully verified project data, through any time it changes hands, right up until it's finally retired by the end user offsetting their emissions. You can track that whole life cycle.
Which sounds like it directly addresses that double counting problem we talked about.
It really does. By giving each credit a unique, unchangeable digital identity on this shared ledger and tracking its ownership and retirement status transparently, well, the risk of someone trying to claim the same credit twice goes way down.
Makes fraud much harder if everything's out in the open and can't be easily changed.
Exactly. That tamper-proof nature is key.
And the automation piece, the smart contracts, how does that improve things?
Smart contracts can automate some really crucial steps, like automatically issuing new credits once certain project milestones or verified impacts are confirmed.
Or automatically retiring a credit once a buyer officially uses it.
Yes. This streamlines the whole process, cuts down on manual work, which can also mean reducing delays in transaction costs. It just makes the market potentially more efficient.
Okay, efficiency and transparency. I also saw the term meta-registries pop up in the sources. What's that about in the context of blockchain?
Think of blockchain acting as a kind of master index or aggregator in that scenario.
Pulling data together.
Yeah, it can pull in metadata, data about the credits from various different places, maybe even from existing traditional registries.
Ah, so linking systems that are currently separate.
Exactly. Bringing that potentially siloed information into one single publicly viewable database, it helps create a more unified picture of what's happening across the market.
So it's about weaving together different data streams, digitizing climate accounting in a way that's more connected and accessible.
Right. Creating that verifiable chain of data, linking the credit itself back to the underlying project information, the monitoring data, all of it.
Back to the actual source of the climate benefit.
Ideally, yes.
Now let's shift gears slightly and talk about something that sounds like it could really change who participates in this market. Tokenization. What does it actually mean to turn a carbon credit into a token?
Okay, so tokenization is essentially representing an asset, in this case, a carbon credit, which usually stands for 1 ton of CO2 equivalent as a digital token on the blockchain.
Like a digital representation.
Exactly. These tokens can be standard interchangeable ones, what we call fungible tokens, like digital currency, or they could be unique non-fungible tokens, NFTs.
So you create this digital asset that you can then easily trade on the blockchain system.
Yes, and that's a really big deal for liquidity and accessibility. Tokenizing makes it potentially much easier to buy, sell, and transfer carbon credits.
Which could open the market up beyond just the big companies or institutional buyers.
That's the idea. It could bring in a much wider range of participants.
And the sources mentioned fractional ownership too. That sounds quite significant for, say, individuals or smaller businesses.
It really is. Tokenization allows a single credit representing 1 ton to be digitally divided into smaller pieces.
So I could buy like 1/10 of a credit?
Potentially, yes. Someone could buy just a fraction. This lowers the entry barrier quite a lot. You don't need to be buying hundreds or thousands of tons at a time anymore.
Makes it more accessible for smaller offsetting needs.
Definitely.
Now, one source made a really interesting comparison. It said carbon credits aren't like gold, simple, uniform. They're more like diamonds, with lots of different facets affecting their value. Why is that distinction important here?
That's a great analogy, actually, because the value and crucially the quality of a carbon credit depends on so many different things.
Like what?
Like, where is the project geographically? What type of project is it? Did it avoid emissions? Or did it actually remove CO2 from the atmosphere? When did the reduction happen? That's the vintage.
Okay.
And maybe most importantly now, what are the co-benefits? Does the project also support biodiversity or help local communities? All these factors influence its perceived quality and value.
So unlike gold, not all tons are created equal. How does blockchain help with that complexity?
Well, this is where smart contracts become really powerful again. The token representing the credit can have a smart contract attached to it that embeds all these specific attributes.
Ah, so the details, the location, type, vintage, co-benefits are coded right into the token itself.
Exactly. It allows buyers to see and differentiate these attributes much more clearly. They can understand exactly what kind of diamond they're buying, so to speak.
And potentially helps direct money towards projects that meet specific criteria, like high quality or certain co-benefits.
That's definitely one of the hopes, yes. Steering capital effectively.
What about NFTs specifically? We mostly hear about them for digital art. How are they used in the carbon space?
Well, one way is using an NFT as a kind of blockchain-based receipt when a credit is retired.
Like immutable proof of offsetting.
Exactly. Proof that this specific amount of carbon linked to this project was offset by you. They can also be used to categorize different types of credits really clearly on the ledger, like visually distinguishing an avoidance credit from a removal credit.
Okay, this all sounds pretty promising, at least in theory. But is it just theory? Are people actually building these kinds of systems today?
Oh, yes, definitely.
Mm.
The sources point to several real-world initiatives that are actively using blockchain. Gildone is a really interesting example.
What are they doing?
They're using what's called a bridging approach. They use a private blockchain Corda, in their case, for the initial secure tracking and verification of the project data. They even talk about potentially integrating real-time data from sensors.
Okay, so keeping sensitive operational stuff private first.
Right. Then they use a bridge, they call it T10N, to create a token representing that verified credit on a public blockchain, Cardano.
Ah, so you get the best of both worlds. Privacy for the sensitive data, but transparency and easier trading on the public chain.
That seems to be the strategy. And a crucial technical detail is that when they create the token on the public chain, they effectively lock the original credit record on the private chain.
To prevent it from being spent or claimed twice.
Exactly. It tackles that double spending risk head on.
That's quite a clever approach, combining private and public chains like that.
It seems quite sophisticated, yeah. And there are others mentioned, too.
Woohoo.
Let's see. Moss, they tokenized credits as MCO2, did some NFT work involving the Amazon. There's Claima.DAO, whose goal was actually to buy up and tokenize offsets to drive up the price. Toucan is another big one, building infrastructure to bridge credits onto the blockchain TCO2 tokens and trying to funnel revenue back to the projects.
Okay.
Then you have Save Planet Earth, working on tokenizing with gold standard verification. Carbon X, Region Network, focusing more broadly on eco-credits for various ecosystem services, not just carbon. And Declimate, building a whole decentralized system for climate data itself.
Wow, okay. So there's definitely a lot of activity, a lot of different approaches being tried, but it can't all be smooth sailing, right?
Yeah.
What are the catches, the challenges, the risks?
You're absolutely right. It's definitely not a magic bullet. And probably the single biggest warning that comes through in these sources, the real potential showstopper if it's ignored, is this.
Go on.
Blockchain doesn't magically fix bad data going in.
Ah, the old garbage in, garbage out problem.
Exactly that. Blockchain is brilliant at recording data faithfully, immutably. But if the underlying project data is flawed to begin with, if the initial verification wasn't robust...
Or if the project itself is just low quality, maybe it would have happened anyway, the whole additionality question.
Right, or these so-called zombie projects. If
Yeah.
you tokenize that kind of credit, all you're doing is putting a low-quality, maybe worthless credit onto a very transparent, permanent ledger.
Which could actually make things worse. Giving junk credits a new lease on life.
It potentially could, yes. It could amplify skepticism if the focus is just on the tech and the trading without rigorous vetting before anything touches the blockchain. One source explicitly warns about prioritizing liquidity over verifying quality up front. That's a recipe for a market full of lemons.
That makes sense.
Hmm.
What other hurdles are there? You mentioned the private-public chain thing, that tension between transparency and data protection.
Yes, that's a real balancing act. How do you provide the public visibility that builds trust while still letting project developers protect commercially sensitive or proprietary information?
Other solutions?
Well, permissioned or private blockchains where access is controlled are one approach, like the Gildon example. But that adds its own layer of complexity and might raise questions about decentralization. Scalability is another potential issue.
Meaning, can the tech handle the load if this market gets really big?
Potentially, yeah. Some blockchain designs might struggle with the sheer volume of transactions needed for a truly global carbon market, though newer architectures are addressing this.
And regulation. That always seems to lag behind new tech.
Oh, absolutely. Regulatory uncertainty is a huge factor. The rules of the road are still being written internationally.
Are regulators paying attention at all?
Yes, they definitely are starting to. The sources mention things like the New York moratorium on certain types of energy-intensive crypto mining, U.S. federal agencies looking into distributed ledger tech's impact, even the CFTC showing interest in overseeing the voluntary carbon market.
And global efforts.
Right. Initiatives like the ICVCM, Integrity Council for the Voluntary Carbon Market, and VCMI, Voluntary Carbon Markets Integrity Initiative, are working hard to establish core principles and standards. That's crucial, but it's still very much an evolving landscape.
Any other barriers? Just practical stuff.
Sure. The cost of implementing this tech, the need for training people to use it, ensuring access isn't just limited to big players, especially for project developers in, say, developing nations. These are real adoption hurdles.
Oh.
And finally, there's that ongoing tension we touched on. Balancing the push for liquidity, making credits easy and fast to trade, with the need to maintain environmental integrity and clearly signal all those important quality differences, the diamond facets.
Right. You don't want to simplify things so much that you lose the crucial details about quality.
Exactly. It's a tricky trade-off.
It definitely sounds complex, but also like it's moving incredibly fast. Looking ahead then, what do the sources suggest is coming next for blockchain in these carbon markets?
Well, a big theme is integration with other technologies.
Like what?
Combining blockchain's transparent ledger with, say, Internet of Things, IoT sensors on project sites.
For real-time monitoring.
Exactly. Imagine getting verifiable real-time data about a forest's carbon absorption or a renewable energy plant's output fed directly and securely onto the blockchain. Or using artificial intelligence, AI, to analyze that data, optimize projects.
So making the data feeding into the blockchain more robust and automated?
That's the goal. Reliable data in, reliable record out. There's also talk about decentralized finance or DeFi.
Using these tokenized credits in new financial ways.
Potentially, yes. Creating new financial products or markets around them, which could bring in more investment, more liquidity. But maybe the most critical piece looking forward is standardization and interoperability.
Making sure all the different blockchain platforms can talk to each other.
Yes, and agreeing on common standards. The market is still quite fragmented, with different projects using different tech, different rules.
So efforts by groups like ISO, IE, IETA, you mentioned the Climate Warehouse Initiative, CAD Trust, those are key.
Absolutely vital. To create common standards, ensure different systems can connect, and basically help unify these currently fragmented markets into something more cohesive.
So the ultimate vision is a more joined-up, efficient global carbon market underpinned by this technology.
That seems to be the hope, yes. And as more and more companies around the world set ambitious sustainability targets, the sources predict we'll see increasing adoption of these kinds of blockchain solutions.
Because they offer a more reliable, more verifiable way to manage their carbon footprint and back up their offset claims.
That's the value proposition.
Okay, let's try and bring this all together then. We started this deep dive looking at a voluntary carbon market facing a serious trust deficit.
Right. Confusion, opacity, worries about double counting, and quality.
And we saw how blockchain, with its core features decentralization, immutability, transparency, offers, at least technically, a pretty strong foundation to rebuild that trust.
Yeah, the specific applications, like clear traceability from issuance to retirement, using smart contracts to automate things, creating meta-registries, these seem to directly target those problems, like double counting and opaque reporting.
In tokenization, that adds another layer. It opens the door for more people to participate, increases liquidity, allows for fractional ownership, plus using smart contracts to capture those diamond facets, the quality details.
Acknowledging that not all credits are the same, which is crucial. And we saw real-world examples like Gildren's bridging approach and many others, showing this isn't just theoretical anymore. People are actively building and trying things out.
But, and this is a big but, the sources were very clear about the challenges. That garbage in, garbage out issue is paramount.
Absolutely. Blockchain records what it's given. Tokenization won't magically fix a bad credit. Quality verification before it gets on-chain is non-negotiable.
Plus, there's the ongoing regulatory uncertainty, the need to balance transparency with data privacy, potential scaling issues, and that constant tension between making things easy to trade and ensuring environmental integrity.
It's complex. The future likely involves more integration with other tech like IoT and AI, and a really critical push for global standards and interoperability to tie everything together.
So it's a powerful tool, definitely has potential, but it's not a silver bullet. It needs careful implementation, strong governance around it.
Exactly. Its technology and the market around it are clearly still evolving fast. Lots of lessons being learned, I'm sure.
It really does raise a fascinating final thought, though, doesn't it? About the power of truly accessible information.
What do you mean?
Well, think about it. If this technology, if blockchain, can actually make the environmental impact of a product visible to you right there on the supermarket shelf.
Or let you easily track with verifiable data whether a company's big offsetting claims are actually legit.
Right. What does that fundamentally change about how we make choices? As consumers, as investors, just as citizens trying to navigate the climate crisis, it feels like it could put a whole new kind of power and maybe responsibility into our hands.